Oh.
So I thought I would cover, since I was one of the original speakers, I can't believe that, and Jason called me up and graciously asked me to be here, and of course I said yes, but he reminded me it had been 10 years. 10 years. I was like, oh my God, 10 years is an awfully long time. Yeah, it also helps from the microphone, doesn't it? I hope you all can hear me now. So 10 years, yeah, it's been a really long time, and I was surprised at that time, but I thought I'd first cover a little bit about kind of what's happened since then, and then dive into some thoughts about what's to come. First, a disclaimer, because I'm a lawyer, I have to start everything with a legal disclaimer. The content in here is fully my own opinion and certainly not representative of AES or any of its subsidiaries. That being said, oops, I'm going to give away all the surprises. 10 years, it's been impressive from where ETS has really, I think, taken the industry by storm. It's really proven to be a critical conversation piece in terms of the dialogue on how we're doing transformation in the industry as a whole. From humble beginnings with Steve Wozniak and Wellinghoff here, pretty good speakers, to today, it's been an impressive 10 years. I've changed over 10 years. My daughter was a lot younger 10 years ago, and now she's considerably older. I'm considerably grayer and heavier than I was. A few teams have won some championships. To make it more interesting, I used to joke always that the schools that I went to, Georgia and Virginia, were the sad sacks of athletics, and that they always got close but never could win anything. And then we've been lucky to actually win a few national championships, so that's been good. On the left, I spent about 20 years at those 4 companies, and on the right, I spent the last 10 years at those companies. So it's been a career change for me, too. And of course, kind of the statement we all know about, we've seen a whole lot of change within the industry itself, right? From kind of fossil-based fuels now to more renewables, more battery storage. More interesting, I think, is some of the companies that have played kind of an interesting role in this transformation over the last 10 years. I've got the market caps for these companies. In automotives, Toyota was a $193 billion company back in 2013, and Tesla now is a $650 billion company. That's incredible growth. Apple, $500 billion, now $2.6 trillion company. Duke Energy was one of, if not the largest utility at the time at around $50 billion market cap, and now NextEra is at $150 billion. So we've just seen a sea change in terms of technology. I think the key thing to note here is that the players who are the winners in today's market cap size are often those that embrace the change the most. And so when we start thinking about what's to come, let's talk about what's just shifted now. So in the early 2010s, renewables, everybody was talking about it coming, but it was really only cost effective in certain areas. Now we've got over 140 gigawatts of installed capacity and about another 29 or so planned for this year alone. That's incredible growth. Utility scale battery storage. I remember we were doing some of the original ones at Duke, and those were, shall we say, entertaining, but really not that affordable, and a lot of the chemistries were based on lead acid. Today we've got almost 9 gigawatts installed and about another 9 planned, and heavily shifted in terms of its chemistry. Early 2010s, a lot of resistance, mostly concerns about reliability, which is always valid, and safety, but also just generally like what technology is going to win and what's it going to do to us. Now I think we have a much better, clearer picture of what's going on and why it's here and what it's to shape. At the same time, EVs and PHEVs, the big EV at the time was the Tesla Model 3, and we had 2 PEVs, Chevy Volt and Toyota Prius, and now we've got something like 77 different versions of these things that are all for sale and a whole bunch more to come. Early 2010s, we were talking about the ERA grants, about how those were awesome and how we were going to roll out smart grid. And now we're talking about the IIJA and kind of its impact on industry transformation. And also, last but not least, we were talking about RECs and offsets quite a bit. And now we're going from that to 100% renewable and 24/7 carbon-free energy, kind of a whole step change in terms of what we're looking for sustainability. So as I mentioned, I'm going to talk about some predictions, but first, I wouldn't be a good lawyer if I didn't give you a whole bunch of caveats. And so the first set of caveats is that I'm going to be wrong about most of these. That being said, you can never tell what curveball is going to come out from left field, whether it be some geopolitical event or heck, coronavirus. My wife specializes in infectious disease. That's her, not only her work, but also her passion. And so these last few years have been like a nightmare, a constant nightmare for her, because it's like her worst fears come true. You've got supply chain issues, you've got all sorts of things going on in the financial system. So all that being said is there's a lot of uncertainty, probably more uncertainty now than perhaps what we were seeing in the early 2010s. So a few thoughts about what's to come. First is about customers, the first category. And for those of you who are not familiar, there's a group called the Clean Energy Buyers Association. They basically represent some of the largest corporations around the world. And by and large, these companies have either all committed to 100% renewable, or they've committed to being 24/7 carbon-free energy. What this means is that if you think about all the new clean energy that's being consumed and built today, about half of it is actually going to these companies, and the other half is going to utilities. What I think coming forward, what we'll see is that as the grid greens, as we become more sustainable, you'll see the corporate activity dying down some. Most of that's going to be based on hedge effectiveness. Most of these companies, they buy renewables as a way to hedge their floating utility costs. And what we'll see is that the hedge effectiveness will diminish because the renewables aren't always necessarily co-located with the load. And so the PPA buyers, the corporate PPAs, while they're going to continue to do a lot of work in this space, some of that will tamp down over time. Another thing about digital technology, while I'm showing two residential or mass market produced items, a thermostat and a typewriter, this is true about all customers in all classes, whether it be residential, commercial, or industrial, is that they're increasingly changing out their analog and mechanical assets for digital ones. To give you an example of that, Google, my previous employer, runs an enormous data center fleet around the world. That entire infrastructure is basically one giant big digital infrastructure that they can then manage to shift load around. They can predict where they'll need to put it, and they can move the load accordingly. This is really important because it represents not what we do with a smart thermostat today in the home, which is already happening, but it represents something at industrial scale. And so what you'll see is that all the sorts of things that are happening, that have happened to help consumers on every day kind of manage their consumption in the background, you'll also see that start to happen in commercial and industrial loads too. And this means that AI-driven models are going to be creating an incredible amount through this digital infrastructure of new demand response capability, stuff that we can't even imagine in terms of size and scale today. A third one is about data centers themselves. They're really going to operate more like power plants. They have marginal cost, and they have the ability, as I was just saying, they have the ability to potentially move load around and dynamically do it. These will increasingly look, act, and feel like a utility, and they will start to become what I would consider operating like power plants in energy markets. So you'll see a lot more of that capability. A thing about oil. There's going to be a ton of pressure to continue to move and eliminate fossil fuels out of industrial, residential, agricultural, and transportation sectors. That's not going away. The key thing to note here is that it's going to take decades to do. It's not going to happen as quickly as we would like, and it's going to probably rely on hydrogen and a few other technologies really coming and bearing fruit. It's not to say that people aren't motivated to do it, it's just that there's an incredible built infrastructure that has to be dealt with here, and it takes time. Same time, EVs, we're going to continue to see EVs and EV infrastructure grow. It's going to be growing quite fast, probably faster than we expect even now. But a lot of internal combustion engines are going to remain. Think about all the cars in the world, only so many of them are in first world countries. A lot of them are in second and third world countries, and that stuff will take an enormous amount of time to build out the infrastructure to support it and replace those assets. And while we're in that kind of interregnum, it's just going to take a long time to get internal combustion engines out of the infrastructure.
Things about oil and gas companies, they're still going to be around. They're likely going to be a big player also in the hydrogen space. And at the same time, oil and gas utilities, gas and electric utilities, they're still going to be here too. But we're all going to be dealing with a lot of employee turnover. Employees are graying, and myself included. But we're going to see a lot more use of things like AI and automation to replace a lot of the more tedious or manual aspects of the work today. And so it's not a bad thing. It's not take over the robots, but it is the way we do work today versus how we'll be doing it in the future will be considerably shifted. We'll see some industry consolidation, and what we'll see is that largely people who've been dabbling or working in this particular space in terms of renewables or battery storage, we'll start to see consolidation into a few key players in the industry that largely have the scale and scope to be able to run these units, these fleets at scale and efficiently. At the same time, we see that we'll still see modest M&A activity in the utility industry, largely driven by the fact that smaller players need the scale and scope that a bigger player can offer, and that while you can still have these sorts of opportunities, they will be limited. Another thing we'll see is that a lot of utilities are going to pick to be a railroad versus what I think of as a telecom company. And what I mean by that, and it's not meant in a pejorative sort of way, but railroads are companies that have defined routes and very predictable, stable earnings and activities for the most part. Telecom companies are aggressive commercial entities that are always growing and expanding and changing. And what I think is that utilities will largely stick to the left-hand side rather than the right-hand side, primarily because it's explainable, it's understood by their investor class, and it enables them to be predictable and less volatile. So there'll probably be a lot of that. Carbon capture and sequestration, the interesting thing about this is that I think that a lot of the initial focus has been on utilities, but I think actually that will shift over time. It'll be more governments and oil and gas majors and less utilities as they green their fleets. Nuclear will remain a critical technology for carbon-free energy. It's got to be. It's a key component in it. But the amount of cost overruns, the delays, the regulatory hurdles, the engineering that's necessary to do this will continue to limit its potential. Meanwhile, you're going to see a lot of investments in storage, and from more traditional things like hydro to more exotic things like molten salt, or on the far right there, battery storage. You're going to see a lot of investment in storage. We can't build and implement all the renewable energy that we want without a commensurately equal-sized investment in storage to help even out that production. Another thing is that Metcalfe's law is still going to hold. I always love Metcalfe's law. It's one of my favorite things to talk about because Metcalfe's law states, for those of you who are not familiar with it, that the value of a network is basically proportional to the number of commonly coupled devices. And what that means is that we always hear these conversations of people wanting to go off-grid, or I want to build a microgrid and kind of do things on my own. And it's all about energy independence. But in reality, the network itself has an incredible amount of value, not just the physical value of being interconnected, but also the cost value of being able to share in the costs and benefits associated with that network. And so I continue to see that Metcalfe's law, no matter what, is going to hold. And rather than being disconnected, we're going to continue to remain connected in the future. Supply chains are going to be a pain. You've got onshoring, nearshoring. You've got all kinds of critical gaps in it. This is going to continue to be a bit of a braking activity on the aspects of decarbonization and digitalization. At the same time, rare earth elements, copper, lithium, all of these sorts of things are going to also be a constraint. We just don't have enough mining capacity in the right places at the right times to be able to do all the things we want to do, or we say we want to do. And so both of these are going to act as somewhat as a braking activity on much of the efforts on decarbonization and digital transformation. At the same time, all of that, if you start thinking about all those digital assets, all those interconnected things that are now smart and intelligent, fundamentally this means that there will be a shift in the architecture of and the operation of power grids. It doesn't mean that we're going to not operate them without a human in the loop or without people doing things in a central office, but it does mean that we will have distributed computing capabilities. It's just inevitable to think about how to manage that system and the complexities that come from it by doing it all in one central location. Not only is that a giant cybersecurity risk, but it's also basically too slow. And so in reality, what we'll see is we'll start to see distributed computing really start to augment the capabilities of our existing ADMS, EMS, et cetera. A lot of the research and development dollars, at least on the grid, are going to go to things like the new digital alternatives to analog devices, and I mean that in the best sort of way. I remember once we were, in a prior life, we were testing a transformer that was entirely solid state. Not only was it huge and did it make the pole kind of sag, which was entertaining, but it represented a sea change in terms of how we think about metering, voltage management, basically a whole bunch of things that normally are kind of typical tactical problems we face on the distribution side of the business. We also found out that as we made the software work faster and smarter on a distributed basis, it rapidly outstripped the ability of the hardware to keep up. And so what we're going to see is a lot of new investment going into this digital infrastructure to replace things that you wouldn't normally think about replacing, but are going to be absolutely critical to doing it, because without it, we can't really get the full benefit. So for example, transformers, the traditional mechanical or analog equipment that you see every day, there's going to be a lot of change in this particular space. We're also going to see a lot of the, as I mentioned, distributed grid management software. Like once again, it's inevitable in terms of how to do these things. We'll see a lot of investment in cyber and physical security. I don't think it's going to be a surprise to anyone to say that these sorts of assets are usually the #1 target on state actor lists. It's also the fastest way to bring a society from a modern world down to the 1800s in rapid short order. And so the security of the grid, how it operates both physically and logically, is going to be critical. And then last but not least, AI-driven predictive and optimization models. This is not a revenge of ChatGPT. I can't tell you how many times I've been asked about ChatGPT. It's on the traditional hype curve. There's a hype that it can do everything, and then we'll come crashing down to reality in terms of thinking it can't do anything, and then it'll actually find its niche and its capability. But it'll take a couple of years. Right now, we're very much in the hype side of that curve. But really here, a lot of the things that if we stop and thought about how we do our work and what we do, what we would see is that we largely follow and attack problems that in a very manual and rote way. And there's a lot of space in here for optimization and predictive models to basically help us do the work that we do and elevate our work from more tactical aspects of what we do into more strategic ones. So I actually view this as a very positive outcome that will actually help us do more work with more than what we do today. Here's another thing, and I love the state of Texas. I've lived here for multiple years and worked for a few different companies here. But what I see is that when you think about your system as an island, and it's not interconnected, either physically or logically, it inevitably has less benefits than being truly interconnected. I mean, once again, Metcalfe's law will prevail. And that what we'll see over time is that more and more pressure on these systems to transform, to ultimately go get the benefits that truly can come from the new infrastructure, the new capabilities. Being an island unto yourself is less and less a good idea. And I suspect that over time that pressure will mount and we'll start to see more integration than we have today. A bit about the legislative and regulatory side. Sometimes I like to start these conversations by saying I'm an ex-Enron employee and that you really shouldn't believe anything I say. Then I tell people I'm a lawyer and that I have no soul. By the way, both true. But I would be remiss in having this conversation about a future perspective without talking a bit about the regulatory and legislative side. For here, the regulatory and legislative side, I think, is one of the key opportunities for us to unblock so much of what we're doing. Read almost any trade press and you'll see conversations about how long it takes to cite transmission or how long it takes to get approval to do anything. Our favorite acronyms, NIMBY and BANANA, that tend to continue to cause great angst as people attempt to solve problems in the real world with physical infrastructure and yet find themselves doing a lot of work to try and get stakeholders on board and do all the hurdles that are necessary to get things approved. I think that pressure is just going to continue to go up, and that eventually it will force some sort of legislative or regulatory fix on the system. People are loath to talk about things like eminent domain or putting timelines on regulatory approval for fear that it's cutting people's voices out. But there has to be some sort of fix that's applied here and done in a way such that we can have meaningful dialogue about where the infrastructure needs to go and what it needs to do and how safe, affordable, reliable, and sustainable it is. We also have to have that in a timely fashion. Otherwise, we'll keep talking about it and wondering why we haven't done all the things that we need to do to really address climate change or address the infrastructure needs of our customers. And we can't do that without some changes here on this particular front. I also see that the government is going to continue to be involved. As I mentioned, we're going to have pressures in our supply chains. We're going to have pressures that are coming in terms of needs for rare earth elements and key minerals and metals. And we're also thinking that a lot of what the government's going to continue to do is to incentivize the transformation that I've been describing here. I don't see that going away anytime soon. I think the government has great policy goals in terms of trying to accelerate that, but also from an equity standpoint, how do you bring those benefits to everyone? And I think you can't do that without government infrastructure investment activities and incentivization activities. So with that, I'm finished with my prepared remarks. I am happy to take questions from the audience and talk about any of these or perhaps any of the other things that we may be seeing on the horizon in terms of what's next in the industry. And since I can't see anyone, I hope you'll call out your name or otherwise wave or do something truly visible. Or I can tell you stories about Google. That's fine. Okay, yeah. So favorite thing I used to do when I was at Google, people would ask me, oh my God, you came from utilities and now you work at Google. It must be so different. And I would say, no, it's exactly the same. And people would give me a funny look, and like, why is it different? Or why is it the same? And I said, well, in a utility, everyone's an engineer. Google, everyone's an engineer. It just happens to be that the primary engineer at a utility is an electrical engineer, and at Google, it's a computer scientist. And I was like, I'm kind of glad I'm a computer scientist. Second thing is, I said, well, utilities have to operate 24/7, 365, and when the systems go down, bad things happen. It gets in the press, right? Same thing happens with Google, right? Our systems go down, and no Gmail, no search. Kind of a big deal. It happens on a global scale. So same emphasis on reliability. Everybody's an engineer. It's also a consensus-driven culture, just like utilities. I mean, when you have that amount of infrastructure, that scale, that size, you've also got to get that amount of people to kind of, get together to solve problems. So very, very similar to utility, but also very different. My 4 years at Google, I saw more growth in 1 year at Google than I saw in 20 years in utilities. It's incredible. I remember thinking, in a utility, you're always thinking about okay, I'm only going to have 10 people to go do something, and this is the 10 people I'm going to have probably for a decade. At Google, we're like, okay, we have 10 people today, but we need 5 more tomorrow, and 5 more after that, because of the scale of the growth. And also within Google, energy is the single largest budget item. I don't know that that's well known, but it is. So it's the most expensive thing Google does. I used to joke with general counsel at one of the major utilities that I had 1.25 billion reasons to go invest in regulatory work associated with them. So there's a lot of similarities and also some key differences. But it was a fascinating place to work.
One learning can you take from that Google experience over to the utility today?
The one learning I can take, well, that one's going to be an easy one, which is go faster. It was funny. One of the worries I had when I've always been kind of in this innovative bomb-tossing space in the utilities. And when I went to Google, I thought, wow, now everybody's going to be like that. And I remember, in a utility, you would typically have in an 8-hour day, you'd have hour-long meetings, and so you'd have 8 concepts you could cover in a day. At Google, you have 30-minute meetings, which means in an 8-hour day, you're roughly talking about 16 different things you can cover. People tend to go a lot faster when they feel the competitive pressure of your competitors breathing down your neck and somebody wants to be ahead of you, and innovation is your lifeblood. I think utilities, the one thing they can really do is embrace that. Embrace the change, embrace the speed. It can be your friend and it can be a competitive differentiator. And as I mentioned from looking at NextEra, who's 3 times the size of the previously largest utility, it can also really help your company financially. So embrace the change, go faster, and I think good things will happen. Don't be afraid to break some things. By the way, on breaking things, an important concept, I never forget, we were doing some work in a past life on one of these things, and we'd written software to basically tell a capacitor to go do something. And we figured out really quick that the capacitor was designed only to switch on or off maybe a couple times a day. We were telling it to do it a lot, such that let's just say it had a mechanical failure. The idea was, and because I'm a computer engineer, not an electrical engineer, I thought, well, hey, it can clearly do whatever I tell it to do in a program, and didn't remember that the physical side has its own limitations. I remember we were having this presentation in front of the CEO, and I told her, I'm like, we only melted a few things. And she looked really worried about that. But I always think about it as taking smart risks, right? We didn't go test this in a production environment in front of a customer's home and light them on fire. We actually had a methodical process of going and testing it in a lab, testing it in a very small area, and then scaling up to a bigger area, and then ultimately to the whole of the company. To me, it's not about breaking things like for the sake of breaking things. That can have dire consequences in our industry. But it means taking those risks in a very smart and calculated way. And that's what I mean when I say go break things, don't be afraid, is have the sense to kind of put those things in place so that you can go fast and you can do things safely and reliably, but you can also innovate. All right. Thank you all very much. Appreciate it.